Alright guys, so here's an explanation of the other night's homework. For the first one, you're picking 3 people for an election, but they're just going to be finalists. They're not going to be any specific order, so it's a combination. So 20 factorial over 20 minus 3 factorial is 17 factorial times 3 factorial. I went ahead and shorthanded this because 17 factorial is 17 times 16 times 15, etc. So by canceling out the 17 factorial with the 17 factorial, I get this. And then from there, I recognize that 3 times 2 is 6. 6 simplifies with 18 to get 3. So 20 times 19 times 3 is 1,140. So there are 1,140 different ways to select 3 people, given that you have 20 to pick from. Now that you have the 3 people, you're picking 3 people. And so 3 factorial is the n. And we had to change up our formula because now it's a permutation. So 3 minus 3 is 0 factorial, and by definition 0 factorial is 1. So 3 times 2 times 1 is 6. So there's 1,140 ways to select 3 people from 20. And then once you have those 3 people, there are 6 ways to elect them in a specific order. Now C was saying to use parts A and B. So you want A and B to occur because you want to select the 3 and give them positions. So you could just simply multiply them together and get 6,840. If you want to start from scratch, you're picking 3 from 20. It's a permutation because the order now matters. So 20 factorial over 17 factorial is 20 times 19 times 18, which is 6,840 as well. Now for 2, you had 9 boys and 8 girls. That is a total of 17 people, and you're picking a committee of 12. So no matter what we do, there has to be a total of 12 people selected. So for the first one, we were just picking 12 people without any restrictions. So that means we don't care if they're boys or girls. So of the 17, that is 12 minus 17, 12 factorial. There's the math. I get 6,188. So there's 6,188 different ways to select 12 people, given that I have 17 to pick from. Now, the second part of 2A got a little specific. Said we want exactly 6 boys. So therefore, we need exactly 6 girls as well, because 6 plus 6 is 12. So we want this to happen, and we want this to happen. So I did out the math. Again, I simplified the 6 factorial and the 6 factorial. So I got rid of the 6 times 5 times 4 times 3 times 2 times 1. Simplified things out. Did it here. I had 3 times 4 times 7 times 4 times 7, or 2,352. So there are 2,352 different ways that I could select a committee of 12 and have them be half girls and half boys. Now the next one was the hardest one, I felt, because you had 3 different outcomes. If you watch the example I posted about golf balls, this was the same thing as the blue and the pink golf balls. And so you want 6 girls and 6 boys, or you would like 7 girls and 5 boys, or 8 girls and 4 boys. Notice how the sum of the combinations add up to 12, 12, and 12, because we're still picking 12 people. So we want this to happen, or this to happen, or this to happen. So I did the math for the 6 boys and 6 girls up above. The 7 girls and 5 boys is right here. And the 8 girls and 4 boys is right there. So I have those 3 different number of combinations, and they all add together because I'm good with one or the other or the third. So that's 3,486. Now 2B was saying, what's the probability of exactly 6 boys? So if I know there's 2,352 different ways of selecting exactly 6 boys, and there are 6,188 different ways of selecting people, given that there are no restrictions, I'll remind you that those are the 2 answers up above. The probability of 6 boys would be that ratio, or about 38%. So hopefully that helped things out. Take a look, and I did post, I want to do a test tomorrow. I explained how we're going to do that, and I think it will work out. Love to hear your feedback if you have any.